source tools we can work for simulations. Before covering any practical demonstration, any specific tool, first of all, we will see different use cases of edge computing, by which way it is associated with other technologies, IoT, IoE, cloud computing, distributed computing, and heterogeneous networks. When we discuss about edge computing, then most of the computations we have to perform on a particular device that is close to human being. In case of IoT, we have to work with the sensors. We have different types of gadgets. We directly communicate with base stations and then satellite. In case of cloud computing, we have a particular cloud data center. We have some specific platforms. We have cloudlets, virtual machines. But as far as edge networks or edge computing is concerned, major computations, most of the implementations we have to perform at a particular device, at human being. Okay, so if we discuss about different use cases where we can use, so very few ways, few use cases we will discuss here, like traffic monitoring, smart agriculture, and nowadays in edge computing, artificial intelligence is also associated. That's why it is interlinked with edge AI. So you also might have heard about this particular integration, artificial intelligence and edge networks, or AI integrated edge computing. And lots of research aspects, research implementations available in this particular segment. So if you are working on such domain, then we have to link with other technologies also. So how to integrate deep learning with edge computing, how to integrate data science with edge, because when we work with edge networks or edge computing or edge devices, on those devices we have to perform some manipulations, we have to perform some mathematical operations. Okay, so whether you are using Raspberry Pi or Arduino, okay, it is not only related to IoT. That is a scenario integrated with edge networks. Okay, so smart traffic light systems, health monitoring, because if we are working on a particular device, a specific gadget for patients, and that particular gadget is able to communicate with remote doctor, so that is a scenario of edge computing, because whatever operations, whatever computations are going on at patient's end, that is edge network, that is edge computing. Because whether it is temperature sensor, humidity sensor, or BP or diabetes level, or uh, whatever parameter we are accessing, so those particular computations are going on at the end of that particular person. In case of smart farming, so obviously if we have deployed Raspberry Pi or Arduino board in a particular agriculture land, so operations or computations or mathematical operations should be performed within that particular device. It should not happen that each and everything we are transmitting to cloud. If we are transmitting each and every data, each and everything on remote system or on remote data center, in that case that will be a separate technology that will be related to cloud or IoT. But in case of edge based networks, edge based computing, we have to work on power optimization, we have to work on bandwidth optimization, we have to work on security, privacy, data analytics at that particular part, at that particular device which is very close to that scenario. In same thing in case of video surveillance. So these are very few case scenarios, these are very few instances, but beyond these, lots of implementation aspects available in edge networks. So major thing is that where we can use edge computing and what is the need of integration of AI and edge. Okay, so you can see, for example, you are working on drone applications for military. So each and so data streaming, video streaming that is going on with a particular sensor with some specific webcam and real-time object detection, real-time object analytics that is performed within that particular device, within that specific object. That is edge network. So lots of other applications, edge AI integrated applications for agriculture. If we are accessing some particular parameter from agriculture land, from farming area, then computations, whether a particular parameter is above or below the threshold or not. So those computations, those measurements should be performed at that specific device. So this is also an area, this is also an instance related to edge computing, but interrelated or associated with artificial intelligence. In same way, if we are using drones for agriculture domain, so before covering any practical demonstration, before covering any specific tool, first of all, we should be clear about different use cases where we can work with edge computing. So you can see whatever parameters we are accessing, whatever objects, whatever land we want to access, whether it is climatic conditions, whether it is related to some weather forecasting. So each and every operation, or we can say that most of the operations, most of the calculations are going on at that particular instance, rather than transmitting each and everything to cloud, rather than moving each and everything to AWS or Bluemix or anywhere else. So most of the calculations should be performed at that specific scenario. For law enforcement, industrial automation, smart ambulance. So one of the very popular example, one of the very prominent example of edge computing, that is smart ambulance, because whatever measurements, whatever calculations, whatever readings we are getting from patient, it should be analyzed within that specific scenario, within that specific premises, and only after performing those calculations, those operations, we have to send final readings to remote doctor, that how much medicine, how much specific injection to be put in that specific scenario. Okay, smart ambulance is 5G powered medical robots. It is also integrated with edge network. Okay, so it is multi-domain. Okay, in diversified domains, we can work with edge computing. But if you are, if your area of research is related to 5G or 4G technologies, in that case also we have to perform operations, manipulations, and algorithmic implementations at edge scenarios. Okay. Now, so up to now we have seen where we can use edge computing, or what is actually case instance or case scenario of edge networks where we can use, but how to implement it. So obviously, if we are doing research in this particular domain, if our area of research is related to edge computing, edge networks, then how to implement it? Obviously, as a research scholar, as a practitioner, we can't afford to purchase so many devices, to purchase so many gadgets for implementations. To perform implementations related to edge networks, related to edge computing, lots of free and open source toolkits available, which we can use for implementation of our algorithms, whether it is related to migration, job migration, process placement, security, privacy, because in edge computing, in edge based networks, lots of areas associated related to research aspects: security, privacy, optimization, bandwidth optimization, placement, migration. So, on which domain we want to work. Now we will see which platforms are available for implementation. Up to now, is it clear to all participants? Kindly confirm in chat. And is it audible, visible to all of you? In chat only, kindly confirm. Whatever we have covered so far related to edge computing, its implementation aspects. Is this clear to all participants so that we can move ahead? Now, dear participants, we will see how to implement. Okay, for example, I want to work on some edge scenario, whether it is related to medical ambulance or it is related to 5G powered medical robots or some migration algorithm. Then which toolkits are available in different paradigms related to distributed computing, related to heterogeneous computing, heterogeneous networks. Lots of toolkits available in cloud sim. In case of cloud computing, generally we work with cloud sim. Okay, lots of other platforms available. You up to now you also might have covered workflow sim. So many other toolkits. Okay, you can use MATLAB, you can use Scilab, GNU Octave is available. Contiki Kusa, hundreds of toolkits available for different types of networks, different types of computing frameworks. As far as edge computing is concerned, lots of toolkits available, different free and open source platforms available, and I will cover in this session two toolkits, two platforms. One is EdgeSimPy and second is NetEdit and Sumo simulator. Okay, I will give you briefing about these platforms. If you are already comfortable in Python programming, you can work very easily with these platforms, with these free and open source toolkits. Specifically for edge computing, for edge simulations. Next generation edge computing simulation toolkit, EdgeSimPy, compatible with Python, and in very less lines of code, in minimum lines of code, we can work with different algorithms, different implementations related to migration, placement, security, privacy, using this toolkit. Okay, so you can see its URL edgesimpy.github. It is available on GitHub and completely free and open source. We can install it in our local Python distribution, whether you are using Anaconda or any other Python distribution. If you are already using base Python 3.6 or whatever version, it will be easily installed. Okay, so you can see this as SimPy. If I want to install it, simply we have to install it with pip installer. Okay, pip install this one. Very soon I will start its implementation. I will show you how to work on this particular platform. I will show some demonstrations of EdgeSimPy in Google Colab. Okay. Its online documentation is also available if you want to go through its detailed documentation. As far as other platforms are concerned, like CloudSim, and if you are already working with MATLAB or Scilab, then each and every platform is having its own programming paradigm, own programming script. As far as EdgeSimPy is concerned, we have to work with Python scripts, Python code. So now I am opening Google Colab so that I can show you some demonstrations related to this platform. as SimPy. At end of this session, I will share this notebook to all of you so that you will be able to work with it. Okay. So this one is Google Colab notebook on which we will execute some demonstrations. I will explain how to work on this, and on in parallel we will see its documentation. Its documentation is available, how to work on this, how to create different types of objects, different types of servers, how to create different types of gadgets. Okay, each and everything is available. Creation of simulator. First of all, to work with EdgeSimPy, we have to install some packages. Network X is one of that. Okay, you if you are already comfortable in Python programming, you might have worked on this platform. Network X for graph networks. If I want to work on graphs, if I want to work on trees, different types of trees, obviously when we work with networks, whether it is computer network or wireless network or IoT based network, then we have to work with connected nodes, connected objects. And if I want to work with connected objects, then we have to install network X library. Okay, so these packages I have installed. Okay, I have specified here network X. And to work with data science, data analytics, to work with some mathematical operations, if we want to work with matrices, distance, if we want to work with security, privacy, so for these implementations we work with NumPy and Pandas for data frames if we want to work with the data analytics part, and for numerical computations we work with NumPy. Okay, and this one is your EdgeSimPy that we can directly install from GitHub. Okay, pip install GitHub repository. Now, before any specific implementation in EdgeSimPy, first of all, we should understand by which way it works. When we work with Cloud Sim or similar platforms, we generally create some cloudlets, we create some configuration, and then we simulate it. In case of EdgeSimPy, if I want to create some servers, if I want to create some gadgets, devices, some base stations, some network, we have to create its configuration file. Okay, so this is very important because without creating configuration file of EdgeSimPy, it will not work. When you will open this particular platform, its configuration file is written in form of data set. Okay, so I'm showing you those data sets. We have to create a data set. Okay, a data set doesn't mean that we are creating some particular data, we are creating a particular Excel sheet. Okay, it is not similar to classical data sets. Data sets in EdgeSimPy, it means that we are creating a configuration file. So I'm showing you the format of data set. Okay, this one is data set. So this type of file we have to create. What is initial power consumption? How many edge servers I want to create? Okay, for example, this one is my base station and its ID is 1. This one is my edge server, this ID is 1. This JSON file we have to create to work with EdgeSimPy. So no need to worry about its complexity. You might be thinking that it is looking very complex, how to create a JSON file of this particular type. So this one is network switch. First power consumption we have initialized, one edge server, and after that second base station. with second base station, how much is chassis power, okay, third base station. So this particular file, this specific data set or configuration file, we have to create. Now the question comes, how to create this type of JSON file. I want to create a particular JSON file, a specific configuration file of my edge network, of my edge computing scenario. For example, 16 nodes, 32 nodes, 5 nodes. For how many gadgets I want to create a specific configuration file of my network. But in case of EdgeSimPy, we will call it as dataset. Okay, so first of all, I will execute it. I will show you by which way it will work. So I am connecting my Google Colab notebook, and then we will see it's working. I will explain how to create its configuration file or data set for execution in EdgeSimPy. Okay, so we are first of all, we are installing this package, this free and open source toolkit. Okay, so all of these required packages are getting installed. So you can see that EdgeSimPy, and along with EdgeSimPy, we will install some packages like NetworkX, MSG pack. And once this particular once these packages are installed, then we can work with our edge network configuration. So it is installed, and this is the programming style. This one is programming style of EdgeSimPy. So you can see this particular function is written in Python language, and this implementation is related to placement algorithm in edge networks. How to place, how to allocate devices and resources to a particular service provider or server. These code snippets are available in official documentation from which we have taken these scripts. Okay, so these functions we can directly call, and you can refer to the official documentation related to EdgeSimPy. Okay, so placement algorithm, you can see that with each and every statement, its comment is specified to list all instances. Okay, so you can see that if I want to access all services, if I want to access all elements associated with a particular object, so for service, all services. So as we are working in placement algorithm, so first of all we have to access all services. So we are accessing those, and after that we want to access all edge servers. How many edge servers are currently available? So for edge server, so we are working on one loop, and with dot all function or with dot all method, we are accessing all edge servers available. So using specific algorithm, so it depends on your research objective, whether you want to work on first come first serve, best fit, worst fit, or in queue, in whatever format you want to work. Okay, so how much capacity is there? If edge server has capacity, so you can see that these functions are already available. Has capacity to host. If this particular edge server, whatever current server we are working, has capacity to host this particular service, then provisioning will be there. Start provisioning the service. Provisioning means we are allocating that particular edge server with specific device. Okay, target server is equal to edge server. So in very simple way we can work on allocation. So this is very simple approach. You can call it as allocation or placement algorithm if we want to work on migration. For example, some services are already allocated, some edge servers are already allocated, and we want to migrate. We want to work on load balancing. We want to work on optimization. For example, our work is related to power optimization, our work is related to load optimization. So in that case we have to work on migration algorithms. Okay, so this particular function, placement algorithm, and this one is your stopping criteria. Stopping criteria means when, at which particular instance we want to stop it. Obviously when all services and all edge servers are occupied, when all available gadgets are allocated to respective servers. Okay, defining a variable whether specific infrastructure is allocated with required gadgets or not. So this one is fixed. So whether you are working on migration or you are working on placement algorithm, stopping criterion will be almost same. And now this one is your major part, this one is your major thing. So I will execute this particular code snippet and this one. Now creating simulator object. Now we will create this simulator, and this one is our data set. So this particular data set, in this particular case we have certain switches, we have certain bandwidth, how much bandwidth we have allocated initially, how much bandwidth demand is associated with specific device. Okay, so how many switches we want to work with, how many switches we want to integrate. Okay, so obviously if we are working on edge networks, we have to work with some switches, we have to work on some servers, we have to work on power model. Okay, so each and every parameter we have to specify in this JSON file. So this one is our JSON file, input file you can allocate. So I will show you on manually created JSON file also. So execute, and on executing, so you can see that this one, to which particular edge server a specific service is allocated or placed. So 6 services and this one edge server. Is it visible to all of you? Are you able to view this? In chat window kindly confirm. Is this visible to all participants? So whatever configuration file we have created. Okay, now we will see how to create this configuration file. So this one is a fix, this particular JSON file is already available in existing data set of EdgeSimPy. If I want to create my own data set file, if I want to create my own configuration file, then how to work on it? Custom model. So I am opening another Google Colab notebook so that we can understand how to create a particular configuration file. Okay, so creating the data set. For example, we want to create this type of data set, a particular data set or a specific configuration file related to this type of network. Okay. We have done certain base stations, we have certain edge devices, edge networks, and for this type of scenario, we want to create a particular configuration file along with some users. Okay, so this one is ES1. ES1 means edge server 1, edge server 2, edge server 3. L1, L2, so these are different links. How many users we want to create? For example, 2 users or any number of users we want to create. So I will share this particular notebook so that you will be able to work on it. Creating edge servers. Okay. How many CPUs we want to allocate? So first of all, we will create one instance of edge server. We have created this one. Now in this particular edge server, how many CPU cores we want to link? 10 cores. So when we work with some systems, when we work with networks, any network or any computing device, we have to allocate, we have to use certain cores. How many cores we want to take? For example, for 10 cores, what is memory? In this particular edge server, what is memory requirement or what is base memory? So you can see this one 4 GB memory. Okay, what is disk size? How much disk space or hard disk we want to use in that specific edge server? If we are working on power related issues, power related implementation, power optimization, or if we are working on energy optimization, so accordingly we can use those parameters. So edge server dot power model parameters. So what is maximum power consumption and static power dissipation, how much we want to allocate. Okay, so in this way, so I want to create a configuration file. So what we are covering here, how to create a JSON file for this particular configuration for this type of network. So some JSON files we have already created. So this one. So this one is your JSON file. Okay, so obviously it is very difficult to create this type of JSON file, this type of edge network configuration file manually. Okay, it will take lots of time and it is structured, it is in very specific structure that is very difficult to be created manually. I want to create one edge network along with its JSON file. For that, we will use this code snippet. Okay, if I want to use 100 cores, if we are working on a supercomputing application, okay, so we can allocate any number. How many cores will be there? If I want to use a TPU, if I want to use graphic card, then accordingly we can set its cores. Okay. So we will see how to work on this. So in this collab notebook also I will install EdgeSimPy so that we can use that particular instance. So we are executing that code using which we will be able to create that configuration file. Is it visible and audible to all of you? Are you getting audio and screen clearly?
Yes, sir.
And So you can see that random seed. So random seed, when we create a particular, when we work on some simulation, then we have to work on this parameter, random seed parameter. Why we use this? So that we can work with reproducible outcomes. Okay, to integrate randomization. Now we will directly come to that particular part. So these two workflows and this particular edge network, and in this particular edge network for which we want to create some elements. So you can see that this one. So one topology we are creating here with 16 objects, hexagonal mesh network. So this one is, you can see that this one is mesh network, this type of network we want to create. And this one is code snippet. What is bandwidth? Topology 1, creating edge server. Now if we want to create edge server for this, so you can see base station. Now you can see that if I will execute same code again, it will give base station 8. So you can see base station 8 by executing same code. Okay, so what you can do, you can execute this particular code snippet in loops also. Okay, if I want to create 100 base stations, if I want to create 1000 base stations, so you can put this particular code snippet in a loop. Okay, or in multiple executions. So you can see that randomization, base stations, base station 6, base station 4. So randomly multiple base stations are getting created. Base station 2. Now if I execute this code, base station 3. So multiple base stations we are creating, and we will be able to work on it. And once it is created, then we have to create some users. How many users we want to create? Okay, so with this particular syntax we can create user object. Mobility model. What is mobility model? And on execution of this particular code, we will get a specific data file that we can directly export. Whatever file we have created, we can download it, and that specific file we can upload in our application. So you can see this one. So whatever edge server we have created, and we want to analyze its different parameters. So you can see that this one is, so CPU, RAM, disk. So by default, so how much power consumption is there at each layer, at each edge server. So if we are working on implementation related to power optimization, if we are working on implementations related to CPU or RAM consumption, if we are working on some resource optimization. So in resource optimization, all of these parameters will be considered. Okay, so you can see as server 1 coordinates, whether it is available or not. Currently it is available, how many CPUs are there, and how much power consumption is there, this one. If you want to plot it, so with Python pandas, you can directly work on plotting part. Okay, so from matplotlib, we can import plot function and bar, or if you want to create some pie chart or some specific donut chart, that we can create. So you can see that this one. And so if we want to work with a particular implementation, so different types of mobility models available. So pathway or random model, user access pattern, whether users are accessing that particular service in circular format or in random format. And this one. So after creating this, as servers, base stations 12, and power consumption. So which particular parameter you want to integrate. So you can see that if you are working on security part, then you can put your security algorithm here.
Hello, sir.
Yes, sir, please.
This HCL that based on Python, since it will work for scheduling algorithm, right?
Yes, sir.
We can try
So
our own scheduling algorithms, like optimization and all we can perform in this particular.
currently it is working on first come first serve.
Suppose if you want to make it our new any algorithm to implement, mean it provide the
Yes, sir.
option.
Yes, sir, definitely. Its documentation is available, so we can access that particular part. Okay, so you can see that, for example, this one is your code. So we can put our code here. Okay, we can customize this specific code.
Okay.
Okay, on GitHub, its APIs are available, and with those APIs, we can customize. For example, we want to create our security algorithm, we want to work on privacy algorithm, so we can integrate that specific. So you can see uh, power model parameters. For example, you can see as SimPy, and we want to see a specific model.
The reading material where it is will get it, sir.
So on its official documentation, it is available, sir. So on GitHub, you will get it. So you can see this one is
Okay.
okay.
The currently
So
what is shown that one is available in the GitHub, right?
yes, sir, yes, sir. Each and everything is available, and by which way we can work with placement. You can see that these are the components.
Okay,
So,
sir.
so you can see placement, migration, routing, scheduling, maintenance. On which part we want to work. So if I want to work with placement, then I will move to that particular library. I will move to that specific API related to placement.
Okay, sir. See, actually, my query is how this particular simulation differ from like a workflow simulation and cloud. So cloud is different.
Yes, sir.
Workflow simulation and this one, like, there's any deviation in that or any specification?
Actually, it is specific to edge networks and associated algorithms. So only those algorithms are available which we can implement on edge devices. As far as workflow simulation is concerned or workflow sim is concerned, in that case, lots of other paradigms we can integrate like scheduling, uh, hybrid scheduling, multi-part integrations. Uh, as far as if we want to, so as far as integration is concerned, edge can be integrated with workflow sim. But if we want to work on edge independently, edge networks independently, or edge AI independently, in that case edge SimPy will be better.
Okay, sir.
Okay, either you can go for edge SimPy, or we can work with Sumo simulator. Sumo, that is for vehicular networks.
Okay.
Okay, so you can go through its official documentation.
Yes, sir. Thank you, sir.
So if we want to get results in specific data file format, we can.
Hello, sir.
Yes, yes, sir.
Hello, I am audible.
Yes, sir. You are audible. Yes, sir. Please.
Hello, I am audible.
Yes, sir, you are audible.
Oh,
Please
sir,
go ahead.
I have one question. Can we implement service function chain
Yes, sir,
using?
definitely. Yes, sir, definitely. You can work on service functions, service provisioning. You can work on different types of scheduling. So you can see that its documentation is available. If you want to refer it, its base research paper is also available.
Okay, so this tool is better or workflow sim is better for simulation of service function chain?
Actually, sir, it depends on your algorithm. It depends on your approach, what you want to implement. Okay, as far as the speed is concerned, so you can see that Python is better. And as far as the cloud deployment is concerned, we can link it with Streamlit. For example, I want to create a graphical user interface of my placement algorithm, of my service provisioning, service chaining. In that case, Python will be better. If you want to work on console, if you want to work on dedicated GUI, in that case workflow sim will be better. Okay, so if you want to work on cloud based GUI, in that case Python based libraries are better.
Okay, thank you, sir.
Okay, so you can see that.
Excuse me, sir.
So this one, so you can see that
Excuse me,
which are
sir.
which are different components. So service, edge server, flow scheduling is available, power models. So which type of power models we can integrate? User mobility, user access. Okay, flow scheduling. Yes, ma'am, one participant want to communicate.
Sir, is there any difference between task offloading using edge computing or service placement using edge computing? Is there any difference?
Yes, ma'am. Actually, these paradigms are related to uh, allocation of some particular services. Okay, so it depends on your algorithm. So actually, it depends on a specific objective on which you are working. What is your base work, on which particular base paper you are working, how many servers you want to integrate, how many devices you want to integrate. So accordingly we have to see how to which particular algorithm we have to use, which specific paradigm we have to use.
Okay, sir.
So what about the installation? We can install along with Google Colab, or we have to separately ID is created.
Both, in both ways you can work. You can work, you can install EdgeSimPy separately, or you can work with Google Colab. Okay, it's up to you. You want, if you want to work with Google Colab, so working with Google Colab is better. Not better. uh, Actually, Google Colab gives you cloud interface. Each and everything will be on cloud. Each and everything will be on web browser. No need to install separately. No need to install on your local system. For example, I'm not having Python in my laptop. We are not having Anaconda. I want to deploy each and everything on cloud. In that case, Google Colab will be better. For example, I want to show my work to my supervisor, to some evaluator. In that case it becomes very hectic if I will install it manually in my laptop. But if each and everything is installed on Google Colab, then I can simply share my notebook. Okay, either you can use Google Colab or my binder. My binder is also available. Okay, have you worked on binder also?
No.
Are you aware with Binder? So it is also cloud-based platform for different types of implementation. So here you will get it. If I want, rather than using Google Colab, if I want to work with Binder, for example, placement algorithm. Okay, so similar to Google Colab, we can execute our code on online Jupyter notebook that is available on Binder. So you can see this one. So within this, I will be able to execute my code. This one, Binder. Okay, similar to Google Colab. If you want to install on Anaconda, it's up to you. You can install, and it will be working.
Yes, ma'am.
And Jupyter will be available in Binder also. Is this clear to all of you up to this point? To some extent, is
So
it clear?
will you share the recording of today's session? It is afternoon session.
Yes, I think ma'am will share.
Sure, sure. I'll share. I'll share.
Yeah, because since it is involved with the installation process, we are not able to follow right. So it will be nice to have your recording, ma'am.
I'll share.
Thank you, ma'am.
So kindly also share the notebook also, sir.
Yes, ma'am.
Okay, I will export this particular notebook, and it will be shared to all of you. Okay. Now, so to some extent, is it clear to all of you? However, in a very short time span, it is very difficult to explain a complete simulator. But just to give you a spark, just to give you an idea how to work on this, is this clear to all of you? To some extent, to 5, 6%, 10%, how to work, how to take a start on EdgeSimPy, how to take start on edge simulations, dedicated platform for edge computing. Is it clear to all of you to some extent or nothing? You can write. Okay, now, so this one is URL. In my presentation also I have given its link how to work on it. Okay, you can explore it. You can explore its complete API. If you want to see examples, different examples are also given. Okay, you can directly execute these examples on Google Colab. For example, I want to execute a migration algorithm. Simply I will click on Colab. Okay, this migration algorithm, its base code will be available, and I will be able to customize. So you can see that how many as servers, what is capacity, what is demand, and with my own parameters I can execute it. So you can see that running the simulation. So very quickly I will show you. For example, I want to execute it, this migration algorithm. And we are executing it on Google Colab. Okay, so this one is algorithm related to migration. Service metadata, each and every parameter, each and every setting is put in this code. And very effective readings we will be able to access. For example, so this is so which algorithm we want to execute. So worst fit heuristic. So you can go for best fit, you can go for first come first serve, or any other approach. If you want to execute your own algorithm, running simulation, for how much time we want to execute. So this one is data set. So as I have shown you how to create a data set, so you can see this one is your output. So it is executing now, and we can see so at which edge server which specific service is allocated. So these readings, these outcomes we can put in our report. If we want to plot, we can use matplotlib, we can use seaborn. Okay, and lots of other implementations available in EdgeSimPy that you can use. Okay, so see examples, lots of pre-built examples, lots of pre-loaded examples available related to EdgeSimPy. Okay, automation of experiments, placement algorithm, monitoring simulations, manipulating components, how to manipulate components, how to manipulate algorithms, different types of algorithms, how to load data set, how to create data set. Each and everything is available. You can explore it. Okay. Now, very quickly, I will cover another platform so that you will be able to work on another simulator related to edge computing, and with a scenario of vehicular networks. If I want to work with smart traffic, in case of edge computing, smart traffic simulation, that is also used. Okay, if we want to work on law enforcement application, if we want to work on traffic optimization, okay, for example, some particular demonstration we want to show that some real-time number plate detection or real-time traffic monitoring. So this is also an example of edge computing. Okay, if we are transmitting data to remote server, it will be associated with the cloud, it will be associated with IoT. Okay, however, in vehicular networks, generally we relate it with IoT or IOV, Internet of Vehicles. But if operations, if manipulations, if measurements are going on uh, within that premises, it will be as it will be a scenario of edge network. So each and every traffic light simulation is edge network, edge computing scenario. When we connect all traffic lights of a city, then it will become smart city. Smart city means Internet of Things. But each and every component, individual component of IoT is edge network. And if we want to work with smart vehicular network for edge computing, for example, your area of research is related to VANET, okay, vehicular ad hoc networks. But VANET is very obsolete. I want to use VANET, I want to integrate VANET with edge, VANET with cloud, VANET with IoT. In that case, we have to work with edge integrated scenarios, and Sumo is one of that. Multimodal traffic simulation. So you can simply download it, completely free and open source. If you are working with vehicular network, with edge computing, or with IoT, for both scenarios it will be working. So you can simply download and install it. I have already downloaded and installed this software. I will show very simple demonstration of this simulator so that you can take a start. Okay, to work with this simulator, we have to start NetEdit. NetEdit, that is also free and open source simulator, that is automatically installed. Okay, NetEdit simulator. When you install, when you download and install Sumo, NetEdit is installed by default. Automatically it will be installed. And here you can work with anything. If you want to work with resource provisioning in IoT, in VANET, if you want to work with service provisioning, migration, placement, but in VANET, not in VANET, but edge integrated vehicular network. For that, we have to work with Sumo simulator. Now I am opening NetEdit very quickly. Okay, NetEdit simulator. This one is dashboard working panel of NetEdit. Now you can see new network. Generally, to work with edge computing or whatever network we want to simulate, we work with scripts. As in EdgeSimPy also we have seen, we have to write some code, we have to write some scripts. But sometimes we need to work with some GUI interface. I want to work with some graphical user interface. Okay, I don't want to script anything. I don't want to work on coding part too much. Okay, in that case you can use this simulator. Okay, not only for vehicular network, if you want to work on railway network, on flight network is also integrated with edge computing, because within flight, within aircraft, whatever operations are going on, that is on edge. But when it is connected to base station, or that we call as tower or air traffic control, in that case it will be radio transmission or IoT. But within aircraft, each and everything is edge computing. Okay, so if I want to create a network, for example vehicular network of two nodes, if I want to create a vehicular network of multiple nodes, so you can see that simply drag and drop. This one is my path, so no need to write any Python code, no need to write any Java code, simply drag and drop. Now I want to work with traffic light, because in edge computing I want to simulate some vehicles and traffic lights. Okay, so you can see that traffic light mode, connection mode, prohibition mode. Okay, so demand. So what I want to integrate, vehicle mode. Now I want to use one vehicle, click. Which type of vehicle? So trip. So from edges, from TAZ, okay, or route. So TAZ means traffic allowed zones. So you can see this path I am creating. So by simply click, I am creating path for this particular vehicle. Finish route creation. At bottom left, you can see finish route creation. Now you can see this particular car is available. One vehicle I have integrated. Another vehicle I want to use. Click. Another vehicle I want to start from here. So it will move from this path to this path. Finish route creation. Two vehicles. Traffic light. Okay. Traffic light mode. Where I want to put a traffic light. Okay. So we can put traffic light. Which type of attribute we want to integrate, and demand. So two vehicles. So very complex networks also we can integrate. So you can see that persons plan. I want to integrate some pedestrians, some persons. Draw vehicle spread. Okay, so only for this part I will show you. Okay, so that it will be very simple for you to understand this scenario. Two vehicles, one path. Even if I want to work on my algorithm, for example, security, privacy, provisioning, chaining, or whatever approach I want to use, I can integrate it with my Python code. Okay, Python script also we can integrate. Okay, each and every vehicle we can program with a Python script or C++ script. It's up to you. If you want to work on GUI mode, in that case also it can be worked out. Now open in on Sumo GUI. So whatever scenario I have created, open in Sumo GUI. So first of all, I will save it. So Sumo 2, any name I can give, or traffic 2. This scenario I will open. Now in which mode I want to work? Standard mode or real world mode? I want to work in railway network. For example, it is a railway network, train network. Train, when connected with base station satellite, this scenario will be IoT. But within train, whatever operations are going on, these are edge operations. Okay, so we can work on that also, or this railway network. Delay, any value we can put, and if I want to execute it, I want to see if there is some collision or not. If our area is related to collision detection, collision analysis, multiple vehicles are moving with traffic lights, with pedestrians, and is there any probability of collision or not? If I want to generate some graphs, if I want to generate some plots, then we can integrate Python code, we can integrate Java packages also. So it is completely free and open source. Okay, so for example, some another object I want to integrate, demand, this one. Okay, finish. And so whether it is power optimization or it is related to energy optimization or congestion control, accordingly we have to see the simulator. So as some participants were asking related to workflow sim, cloud sim, and uh, EdgeSimPy. So it depends on your implementation. So where you want, on which scenario you want to work. So if your area is related to vehicular network, if your area is edge computing but on vehicles, in that case Sumo will be better. If your area is related to classical edge networks or heterogeneous edge networks, but nowhere connected with any vehicle or any mobility, in that case you can use EdgeSimPy. Okay. But to whatever extent, to any extent, if your area is related to vehicular simulation, in that case you can go for this. If you are working on smart city, smart traffic light simulation, in that case you have to migrate to this platform. So any number of objects you will be able to integrate. So edge modes, this one, this one. Data, data sets. If you want to import your own data set, if you want to integrate your own data set, that can also be attached. So you can see that in between joints, in between connections, routes, and so smart traffic controller. In this way, and okay, so you can explore this platform also, Sumo, for simulation of urban mobility or smart traffic for with edge network. So not only for edge, for cloud or for IoT also, if you are working on IOV, Internet of Vehicles, in that case you can use it, or as SimPy. Okay, is this clear to all of you? To some extent, are you getting these contents or not? And how much it is looking easy or difficult to work with? How much it is looking easy or difficult to work with and adaptable. Major thing is how much it is looking adaptable. Okay.
So we have to work out and it will feel, sir.
Okay, so you can set different parameters. So you can see that this one, person mode, one person mode, persons you can associate, finish route creation. So you can see the edges, bus stops, junctions, train stops, and I'm sharing this presentation to all of you. So at end of this presentation, I have put some scenarios on which you can work. Okay, which are different research implementations, which are different research perspectives related to edge computing, which you can simulate. Okay, you can take as an exercise also. Okay, however, it is not an official assignment, but it is basically it can be taken as one exercise that you can take. Okay, how to simulate a smart traffic light system to your students. Okay, as all of you are teachers, all of you are professors, to your students you can give these implementations. So how to create edge based health monitoring system, which components will be there, what will be used. If you want to create a smart farming, simulation with edge computing, then how to work on those. So these are some project ideas or some implementation perspectives related to edge computing that you can propose, that you can suggest to your students for their minor or major projects. Okay. Now, dear participants, I am sharing this presentation to all of you. Whatever I have covered, I am uploading this presentation on Cloud Link. Its link will be shared to all of you in chat window. If you have any query, you can ask any query from participants. Session is open for your queries. I have shared link of the presentation in chat window. Any query from participants? Session is open for your queries. And how much it is looking easy or adaptable, how much it is looking usable for your work if you are working in this domain, whether it is edge-based vehicular network or edge computing with different algorithms. Am I audible to all of you? Kindly confirm.
Very useful for IoT related projects, sir.
Sir, it is looking very easy for the student also, so that we can also plan to make some major projects or minor projects. So it is really
Yes.
nice.
Yes. So any other participant, any participant who wish to communicate, any query, session is open for your queries. If you have any query, you can unmute or you can write in chat. Okay, if there is no query, then should we conclude this session? Kindly confirm. Yes, definitely any algorithm we can implement, whether it is placement or offloading or migration. Okay, so that is part of optimization, that is part of load balancing. Okay, so if you are working in load balancing, load optimization, so in that case you can implement, you can simulate offloading also.
Sir, kindly share the notebook also.
Okay, okay, fine. I'm sharing notebook also. On same link, I'm sharing that notebook. On simply refresh that link which I have shared earlier, and you will get the notebook also. On official documentation of EdgeSimPy, you will get these notebooks. Any other participant? Any query you can ask. After that, we will conclude this session.